Hello everyone, I am Harshal Devkate from MIT Academy of Engineering, and I have designed an event parity generator using Xilinx which checks the data integrity during transmission. So basically the purpose of an event parity checker is to verify if the number of ones in a 4-bit input plus a given parity bit results in an even number of ones. If the total is even, then the output will be 1. If the total is odd, then the output will be 0. This is the truth table for the event parity checker. Here you can see that first we have to count the number of ones in the inputs. We have taken the inputs as A, B, C, P. If the count of ones is even, the output is 0. And if the count of ones is odd, then the output is 1. So for the simulation, I have used this Xilinx software. You can see that first you have to go to the projects file section and tap on new project. After that you have to create the new source and give the port details, then the screen will appear and you have to type the code. I have already done that part. You can see the synthesis code. So the firstly the parity checker will take 4-bit data input, data underscore int, and a single parity bit input, parity underscore it. And these two inputs will generate an output, parity underscore out, which will be 1 if the parity is 1 and 0 if it's odd. In the architecture section, we are going to use a simple XOR operation across all bits of the data underscore int signal to determine the parity. If the result matches the input parity bit, then it is set to 1, confirming even parity. Otherwise, parity out is 0, indicating a parity error. Now, this setup will provide a efficient way to check for single bit error in transmission data. Now, after this, you have to click on check syntax. And if the syntax is correct, then your code is correct. And we have to view the RTL schematic. I have done it already. You can see here the RTL schematic of the event parity checker. Then you have to go to the new source and create the test bench where you are going to write the code for the test bench. You can see here the code written for the test bench. So first we have to assign 4-bit values to data underscore in and sets parity underscore in accordingly to check if the parity underscore out correctly indicates even or odd parity. In each case, the test bench waits for 10 nanoseconds to allow the simulation to capture the output before moving to the next test value. This process verifies that the design works accurately by ensuring the output aligns with the expected parity result for each test case, confirming the functionality of the event parity checker. Then again, you have to go to the behavioral simulation. Then you have to check the syntax for the same, and then you have to click on simulation. And here we can see the simulation for the event parity bit checker. Thank you.